foundation for inference for one mean and how to use the t-distribution in that process. So now we're going to jump into an example. This example is about the blue whale, the largest animal inhabiting the earth. And they tell us the individuals have been over 100 feet long, but 80 feet can probably be considered average. We're going to tuck this number away for later as kind of our assumed average length of the blue whale. And there's just some interesting information, not important to the problem given next. I find it fascinating. You can visualize it as about 3 school buses put together, and the heart is the size of a small car. That's pretty incredible if you ask me. And here's our real question though. It says researchers are wondering if environmental factors like climate change, pollution of the oceans, whaling, any of that has caused changes in the length of the blue whale. So there's our research question. It doesn't say making it shorter or making it longer, just has it changed? So to test this question, we're given a random sample of 15 whales. So I'm going to jot this down for use later. N is 15. And of those 15, they had a mean length of 75 feet. So that's X bar because it's coming just from a sample of 15. So X bar, 75 feet. And the standard deviation of those 15, we're going to use the notation for standard deviation of a sample, was 13 feet. And we want to answer this question, has there been any change in the length, using a confidence interval and a hypothesis test, and kind of note how these two are going to agree with each other. And again, as a reminder, seeing if there's any change, we're referring to this kind of fact sheet understood number of 80 feet in length. So let's start off with our confidence interval first. Let's do a 95% confidence interval. And as a reminder, this is an interval to estimate mu, the population mean. So we need our usual pieces for a confidence interval. Our point estimate. If we're estimating the mean of the whole population, our point estimate was X bar, the mean of the data. No work required. They tell us that's 75 feet. We need our multiplier that gives us our level of confidence. Since we're talking about means, we're using T star instead of Z star. And we said find that either using inverse T if you have it on your calculator. If you do not, check it out on the table provided. Since we want 95 in the middle, that leaves 5 left over, or 2.5% split equally on either side. And we need our degrees of freedom to say exactly what shape this t-distribution takes. That was n minus 1, so in this case 14. Here's our n of 15. That'll give us the negative value. Just make it positive. We actually found this one in the last video. This is a value of 2.145. If you want to pause, make sure you can find that on the table as well. Go for it. Then the last piece we need is our standard error. Remember our usual parts: point estimate, multiplier, standard error. So our standard error, we said earlier, was S over square root of n. So they tell us S, the standard deviation, was 13 feet. My sample size was 15. If you work that out, you should get 3.3566. If you, again, round that to 4 places. So we can start putting that all together. Remember when we multiply multiplier and standard error together, that gives us our margin of error. So that's our 2.145 times the 3.3566. Notice not everything needs to be decimals now like it did when we were talking about proportions. And that is perfectly fine. So we get 7.2 here. So our confidence interval, putting it together, is our point estimate. What is the evidence from the data? Plus or minus our margin of error. So in this case, the data gave us a length of 75 feet on average, plus or minus this margin of error of 7.2 we've calculated. And go one more step, make sure you subtract first 75 minus 7.2 to get 67.8, our lower endpoint, and then add to get 82.2, our upper endpoint. Notice these are not proportions anymore. This is an average length, so we can get all kinds of values now. Our interpretation is going to look very similar. We're going to start off by saying how confident we are. So I'll say we are or if you want to be formal again, this study is, that's fine as well. We are 95% confident. And we've been saying proportion for so long, be careful and say mean. We're talking about means in this case, and the population mean length for the blue whale. So we are 95% confident. The mean length of all, so this tells me this language here, I'm talking about a population mean. The mean length of all blue whales is between, and give our interval here, the 67.8 feet and 82.2 feet. Notice I have units now. When we were talking about proportions, we didn't have units. Now we do. Make sure to include that. Okay, to end this video, before we go to the second part of our example, let's think about what we expect to happen for our hypothesis test. So this is kind of noting the duality, or thinking about what's the confidence interval going to tell me about the next step. So I'll ask it this way. I'll say, question, what would the conclusion be in a hypothesis test with the null hypothesis, kind of that status quo mean length of 80 feet, versus our research question, HA, that the mean is not equal to 80 feet. Or in other words, has there been some kind of change? Okay, so that's our question. Without actually working out the hypothesis test, we should be able to answer this and figure out the conclusion based on our interval above. Okay, so if you check out our interval above, here's our interval. What important number is in this interval between 67.8 and 82.2? Hopefully your mind is telling you that 80 feet is in between those numbers. The null hypothesis, 80 feet, falls in our confidence interval. So again, up here we said we're 95% confident. The mean is between these two numbers. So that's like saying we're 95% confident. We can't rule out 80 as a possibility. It's in that interval. So I can't rule this out as a possibility. I don't have proof it's different than 80 feet. 80 feet's contained in here. So our conclusion, remember when we write our conclusion of a hypothesis test, that always tells us how much evidence we have for HA. So I'll say there is, I'm going to leave it blank for a moment, blank evidence that the mean length is different than, that's my HA, are 80 feet. So we said 80's in the interval. We can't prove it's something other than 80 feet or it's different than 80 feet. We can't prove that. So that means I should have little to no evidence that it's different than 80. Could be. Can't rule it out. Okay, and again, our reasoning is because 80 is in the confidence interval. All right, our last video in this section will actually work out the hypothesis test to make sure we can come to that conclusion.